Yeah, today we're going to continue our discussion of describing quantitative data distributions. In this case, we're going to be comparing two or more distributions. So this is a problem I grabbed from page 85. We have a couple stem and leaf plots. Histograms, stem and leaf plots, dot plots, they tend to take on the same type of visual display. Obviously, in a histogram you have bars, in a stem and leaf plot you have numbers, and in a dot plot you have dots. But we can talk about comparing them in the same sort of way. And when we're comparing them, we want to hit the same features that we would when we were just describing one histogram or one stem leaf plot or one dot plot. We want to describe the shapes. We want to talk about any unusual features, the center, and how spread out the data are. So here we're talking about investment performance in all of the states, and they've taken and they've broken those states up into two specific regions, the South and West, the Northeast and Midwest. And so the way that this plot works is that the stem is inside, so this A8 represents 80. So if I go to the right, that means 88. To the left, 88, 87, 87, 85, so on and so forth. So we can use the same stem, and on the left side here we have a distribution for the South and West. On the right side we have a distribution for the Northeast and the Midwest. And these are percentages above or below average according to this nest egg index. So one thing I like to do is sort of trace the shape. So I'm just going to trace these shapes of these distributions. And there's not a lot of data, so it's not giving us a really great look at the shape, but we might say that to compare the shapes, that in the South and West, this data is approximately symmetric. And we would say that in the Northeast and Midwest, the data is slightly skewed, and we'll say skewed to the left, even though this is turned on its side. We call the left the lower portion. So we would compare them by saying their shape, by saying in the South and West, the distribution of nest egg index is approximately symmetric, while in the Northeast and Midwest, it's slightly skewed to the left. We could mention that there doesn't appear to be any unusual features about each of the distributions, so nothing of note to say about outliers or gaps. We would want to talk about the center. It looks like in the South and the West that the center of the data is somewhere in here, in this stem. And the center of the data in the Midwest is a little bit higher. We would say it's somewhere in there. So we could say something like, on average, the indices in the Northeast and Midwest are higher than the South and the West. Using that language, comparing them by saying that in the Northeast and Midwest, on average, the indices are higher than in the South and the West. And the other thing we want to talk about is the spread. Well, in the South and West, we stop here, but in the Northeast and Midwest, we keep going into this 111, 112, 114%. So in the Northeast and the Midwest, the data is more spread out. So we can say that when there's more spread, there's more variability in the data. And so in the Northeast and the Midwest, the data is more spread out. There's more variability in the data. So here we can compare some box and whisker plots, and it's pretty much the same thing. We still want to hit all the key elements, the shape, unusual features, center, and spread. And what's nice about a box and whisker plot is you can see one of our important unusual features, the outliers. And so we can still sort of trace these. not going to be the best. That box here, since it represents 50% of the data, is going to be where your bump is. And so you can see that the wooden type roller coasters are more symmetric, approximately symmetric, and the steel roller coasters are going to be slightly skewed to the right. Right skewed because this is sort of the upper end of our speed. So if we were comparing the shape, we would say that the wooden type roller coaster distribution is approximately symmetric, while the steel roller coasters are slightly skewed to the right. There are no unusual features for the wooden type. You can tell because there's no dots, but we do have this important outlier on the steel roller coasters that's at about 120 miles per hour. So this must be some special type of roller coaster that they have at an amusement park. If we talk about the center you can see here the medians. And the median for wooden type roller coasters is lower than for the steel. And you can say most of the wooden type roller coasters, about 75%, because the box is 50, this whisker is 25. About 75% of the wooden roller coasters are slower than the majority of the steel ones, because about 75% of the steel ones are above the 75% of the wooden. And of course, the speeds have a larger range for the steel coasters. They're spread out amongst a bigger range of speeds than the wooden. So wooden roller coasters go from about 40 to 80 miles per hour, while the steel go from 40 to 100, with this outlier at 120. So again, we're analyzing both box and whisker plots and comparing them using their shape, unusual features, center, and spread. And so sometimes we can compare different displays. So different displays can show us different things. This histogram will show us that it looks relatively symmetric, approximately symmetric here. I probably should do a better job there. Approximately symmetric. We can see that the bulk of the data lies between 16 and somewhere in here around 23, 24. That's where the majority of the data lies. But then when we look at the associated box and whisker plot, we see a couple of things that are unusual. We see some unusual features. Those two dots represent outliers. And you can see that this shows us that it's a little bit more skewed to the right than we might think it was by looking at the histogram. So sometimes having a box and whisker plot can be helpful because we can identify the outliers. We might have thought that these two boxes over here were potentially outliers, but since they're right up against the rest of the data, we might not have claimed that. So the important thing here is that we can see the outliers in this display. No questions today again. I promise I will get you some questions at the end of these lessons soon, and we'll talk about this lesson in class.